Something we can do in this section of our work is finding a sample size. The idea being that maybe the researchers have an idea of what's happening with their sample in terms of a proportion, or even the notation that we use here, and I'll write this out once we talk a little bit more. It could be the idea of a population proportion that they expect to come through. So knowing the proportions that'll be at work, having an idea of the confidence level you want to work at, and then also what they could do is say, okay, for error, we're going to allow 2% error or 1% error. They might have an idea of the margin of error that they want to allow. And with that, the question might be, so how many people should we survey? If we want this level of error and working with this level of confidence, how many people should we talk to accomplish that idea? So that's what this formula is right here. So in terms of notation, you'll see a lot coming from what we talked about before. In fact, this is even coming from, if you remember from our formula, so margin of error, which is being written as ME for short here. So margin of error was that calculation of Z star times the square root P hat Q hat over N. This formula is just the rearranged form of that, solving for n. So if you did a little bit of algebra and solve for n, you'd end up with this formula right here. There are a few other versions of this formula you might see across other resources, but this one I find is easiest to plug into the calculator and work with. So in terms of the problem, we'll have an idea of a proportion, and then if you have P, then you have Q. This is where I was talking about, so this notation here is referring to a sample proportion. They might say some information in terms of population proportion, or at least an expected proportion, and this formula would just be the same. So if they have wording for P, you can use the same formula as you would with sample data. Z star will come from our confidence level, and then ME, this will be something we haven't seen yet where they describe a margin of error that they want to use. Now solving for sample size, so it's the idea of how many people do they want to survey. When you get to a final answer, we will want to round to a whole number with these. And something that we'll want to do is always round up. No matter what the decimal place is, we'll always round up. So if you get 10.8 out, you'd round that up to 11. If you got 10.2 out, you'd round that up to 11. So even though 10.2, we would normally round that down to 10, with sample size, we want to round up to 11. I'll explain why when we get to a good example to give you the context of why it's good to always round up with these. So let's look at an example. So it's believed that 25% of adults over 50 never graduated high school. We wish to see if the same is true among 25 to 30-year-olds. So this right here that they're describing is a proportion of this population. So we have this proportion of 0.25, which means we also have Q of 0.75, so 1 minus that value. And then they want to know how many of this younger group must we survey. So that phrasing right there, what they're getting at is how many should we survey? So they're asking, what is n? What is our sample size? They want to estimate within 6%. So that wording there, this is a way of wording it without directly saying margin of error, and that they want to estimate it within a certain percentage. So that would be our margin of error. And for this section with proportions, it'll be given as a percentage. So just change it to the decimal form. So that would be a margin of error of 0.06. And we want to work with 90% confidence. So Z star should be the 1.6449. So with that, we have everything for our formula. So n equals, we're going to take our proportion of 0.25 times 0.75. And then times, in parentheses, we'll take our Z star over margin of error of 0.06 and square that. And then for solving, what you should do is just plug into the calculator all at once. I've seen with students before, if you try to simplify step by step with this and piece by piece, rounding error occurs, and you can get an answer that's very, very different from the real answer. Mostly it comes from rounding anything inside here. If you round that and then square it, it's like any error that you had from that calculation just got squared. And then with multiplication, it's just multiplying to larger and larger. So you'd get something very different out there. So with this, go to a calculator and plug it in all at once, and I'll show you how to do that with our Desmos calculator. So your proportion 0.25 times 0.75, and you can start parentheses, and you'll have a 1.6449 divided by 0.06, and then close those parentheses and just make sure the square is on the outside of those parentheses there. So I just close the parentheses and then hit the square button, and that's 140.9217. So let me just write that out for us, 140.9217. And then our usual rounding rule would say round up, but just to emphasize that we always round up. So this would have a sample size of 141. So we should survey 141 of this younger age group. All right, let's do the same thing again, but now what we're going to do is adjust our margin of error to 4%. So we're going to change margin of error to 0.04. So with that, I'll use the same formula as up above. We'll have 0.25 times 0.75, 1.6449, margin of error of 0.04, and squared. And something that I really like about these online calculators, if you still have that saved in there, you could just edit. So I just want to change that one number there to a 4, and that's a 317.0738. So 317.0738. And here's a case where we would usually round down, like rounding to 317, but that would be incorrect here. We want to round up to a larger sample size of 318. So we should survey 318 of this younger age group. So why we want to round up here is due to minimizing error. So with larger sample sizes, we have better accuracy. The larger the sample size, the better. As we use small sample sizes, there's a lot of variability and allows for error. So the idea here is we say we want 4% margin of error. Well, to have exactly 4% margin of error, we would need the sample size of 317 and a little bit more. If we round down here, if we went to 317, we're letting a little bit more error in. So we'd actually be increasing our margin of error. It would be by a teeny tiny amount, but the idea is if this was a work assignment and they said, we want to keep this at 4% error, and then you did this whole report and said, actually, there's more error, they probably won't be too happy about that. However, if you bump up the sample size, then what you get is less error. So, and this is just a guess, maybe this is operating more at like 3.8% error, 3.7% error, which generally the less error you have, the better. Your boss would probably be happy that you actually decreased the error as best you could instead of letting more error in. So with these, always round to a whole number since we're talking about number of people or number of things to survey, and then always round up so that you're not letting more error into the survey.